All right. Let's go. Today we're going to try something a little bit more difficult than we usually do. We're going to take a look at the Animate shader example in the bevy repo, which produces the output that you see on the screen right here. To give the TLDR of what this is actually doing, it is using a lower level API than we normally use on the channel. So instead of using the new material APIs or the as bind group derive, this is dropping down into a bit more of a manual, a bit more of a lower level, a bit more of a using the pieces to put things together level of Bevy API. So the Animate shader example is made up of two files exactly. It's made up of this animate shader.rs file and this animate shader.wgsl file. The animate shader.wgsl file has two shader stages, lifetimes. I think they're stages. So it has a vertex shader here, and then it has a fragment shader. Now, we don't really care about the logic too much, so I guess we'll leave that to later. Suffice it to say that there is a shader that is written here that is converting some colors around and doing some stuff and mixing some colors and then outputting it at the end of the fragment shader. In this case, it gives this, flashing cube. So the really important piece of the WGSL in the shader is that we are using the time since startup here, which is getting injected as a bind group. So bind group 2, binding 0 is a uniform that is a read-only value. That is the time. And we have defined that buffer on the Rust side to be a buffer with basically a single F32 value that we keep setting and setting and setting. So this time since startup keeps increasing as the actual time in the game increases. So let's dig in because there's a lot here. We start off with the default plugins and we add this custom material plugin. We only have one function here. It's the setup system. So that'll run once. It'll spawn what we want to spawn in and then it'll be done. So the really important thing to note here, because we're working with lower level APIs, is that this custom material plugin is just a plugin that we've created. So if we look down where that is defined here on line 61, it's just a struct and it's just a regular bevy plugin. It is not the material plugin that is the higher level material API. So our setup function is the only system that runs. It runs once. It accepts the commands so we can spawn things in, and we also get the mesh database, basically the assets database for meshes. We spawn in a cube with a size of 1, so a unit cube. This is a little bit different than the way that we would normally do this. The way we would normally do this is maybe spawn in a material mesh bundle and then set the material equal to the custom material and set the mesh equal to the, cube mesh or whatnot, and then set a transform on that bundle. But instead of that, what we're doing here is constructing our own kind of ad hoc bundle. So in Bevy, you can use the, bundle derive, or you can implement bundle yourself or whatnot for your own structs. But for tuples, so a tuple of multiple values, those already have bundle implementations. So we can just kind of like ad hoc slap things into a tuple, and then all of these components get inserted on this thing that we've spawned, this entity. So here we're spawning in the mesh. In this case, a mesh handle, or a handle to a mesh. We're spawning in a transform to move the cube around a little bit. It's just slightly above exact center. We insert global transform because if we don't insert global transform, then our other transform component won't work. And then these visibility and computed visibility components are new in Bevy 0.8. We, by default, I believe the visibility is hidden. So we add these in so that we can actually see the cube that we've rendered on the screen. The only other component that we insert here is the custom material. And I'll note that the custom material, when we define it, doesn't have any fields. So this is a unit struct, and we haven't used it as the material in a material mesh bundle. So what we've done here is basically the same thing as inserting a material mesh bundle, except we've constructed our own little ad hoc bundle. And then, of course, we have to have a 3D camera to be able to see anything in the scene. So we insert a 3D camera bundle at something looking at our cube. And that's it for the setup system. Everything else is going to be code that is responsible for setting up values, setting up buffers, and sending that data to the GPU to be used. Again, our custom material is a component. Normally, when we are working on this channel with shaders, we would use impl material for this custom material, so the material trait, but we aren't doing that this time. We're only implementing component. or we're deriving it in this case. The custom material plugin is just something that we use to organize anything else that we're going to add in. So in this case, it's going to be anything that we add to the render world or anything that we add that is relevant for extracting the time or sending things to the GPU. So if you've never seen a plugin before, it works exactly like a normal app works. So we get a reference to an app, it is a mutable reference, and then we get to add systems and resources and anything we want to it. In this case, we start by getting the render device. The render device, if you look at the bevy docs, is the GPU device responsible for creation of rendering and compute resources. So it's basically like getting the GPU here. And one thing you'll notice as we go through these types is that they are, some of them turn out to be light wrappers around WGPU, which is a Rust crate. So in this case, we create a buffer on the GPU using this description. We give it a label, which makes it a little bit nicer in case we have to debug something. The size of the buffer in this case is going to be the size of an F32, and we're going to treat that as a U64. So the size of an F32 would be like 32 bits, and we're going to use that as a U64 value to pass into the size. We have to define how we're going to use this buffer before we can actually use it. So in this case, we've used buffer usages, and buffer usages is just different ways you can use a buffer. Imagine that. The first one we have is uniform, which allows us to insert this buffer as read-only data in a binding or in one of our shaders. The other one that we use is copy DST, and copy DST allows us to treat this buffer as a destination to copy things into. So remember that this is a buffer on the GPU. Then we've got a couple of extract component and extract resource plugins. If you remember from previous videos, there are a number of render stages that happen in order. So we start with extract, then we prepare our values, then we queue up the bind groups, and then we render, and then we clean up. So extract is one of the first things that happens. In this case, these are plugins that make it easier for us to extract either components or resources. And you'll note that this describes it as this plugin extracts the components into the quote render world. The render world is what we are about to deal with down here. So there is let's say there's a set of systems that you run in a normal bevy app, and those have access to all of the resources that you insert and things like that. But one of the things that you can do in bevy is create additional worlds and then use those to do other things. So it's like basically a sub application, and bevy has one called the render world or the render sub application. So these extract components pull values from our regular bevy systems and apps into the render systems. And we do that for our custom material component, which is a unit component, so it doesn't do anything, and our extracted time, and time is something that does actually do something. Then we get the render world so that we can add systems and things to it. That allows us to add a render command called draw custom. Draw custom is something we'll go over later, but I will show you where it's defined down here. Most of these are imported, except for this set time bind group, which we'll go over right down here. And that will show us basically how all of these other ones are implemented. So this defines the draw function that gets called when we actually want to go render this. We insert the resource that is called time meta. This contains the buffer that we're going to write our time values into, as well as the bind group. One topic that we haven't covered yet at all in any of the videos really is custom pipelines or specialized pipelines. So we can define our own pipelines to do different things inside of the bevy render world. And we do that by creating our own struct and then implementing things for that struct. In this case, we initialize the custom pipeline resource, which is just a struct name. It doesn't need to be named custom pipeline. It could be named anything else. And then we also have to initialize our specialized mesh pipeline with a type argument of the custom pipeline. The last three things we do are three systems. So before we were talking about render stages, we were talking about the extract stage, the prepare stage, and the queue stage. Those happen in the order that I just said. So first we extract the time using this extract resource plugin. Then we prepare the time, and then we have to queue the bind groups up to send them to the GPU. And that's what these functions are doing. So that brings us to the extract component implementation for custom material that's used in this extract component plugin. And it doesn't do anything. It just returns the unit struct that is custom material in this case. So we'll skip that for now. Queue custom has quite a few arguments. I don't think we're going to dive into all of these individually. This is basically allowing us to set up all of the draw functions that we want to call. So in this case, you can see that we're accessing the resource that is all the draw functions for transparent 3D. And then we get the ID for the draw function that we've defined later in this file called draw custom. And later on in this function, after we've set up a bunch of things or gotten some things that we need to pass in as arguments here, we can then see that we define the draw function for this pass as a draw custom. Here we can see our extracted time. So this is the place that the time gets extracted from our, regular bevy world into the render world. And all we do here is take the time, so the time seconds since startup, and we pass that into the struct. And that this gets called anytime we need to extract this resource. And this is how we get the value. So it's the same way that you would do it if you were, say, querying res time. You would get time here. Time comes in as an argument, and then we get the seconds since startup. So now time is stored in the extracted time after the extract stage of the render. Then we come to prepare time, which is the next stage to happen. After we've extracted this value into extract time, we can then run prepare time. Prepare time allows us to access the extracted time and as well a mutable resource called time meta that we've defined right here. We talked about it earlier. It's the buffer that we are storing on the GPU. In this case, we take the render queue and we write into this buffer at this offset with this data. In this case, we're using this cast slice. We are turning the seconds since startup into a slice because remember, our buffer is entirely one F32, but we do need to represent it as a whole buffer. And theoretically, we could have multiple values here. So now that we've extracted the time and then we've prepared the time, we have to queue up the bind group specifically so that we can have the time. So we get the render device again, that's the GPU, and we use that to create a new bind group using this descriptor. The descriptor, we don't set a label. The layout is the time bind group layout. We haven't gotten to that yet, so we'll see that in a little bit here in the custom pipeline from world implementation. But basically, we have seen this part before where it's setting up a bind group descriptor with a bind group entry. The binding ID is 0, and the resource is the buffer as the entire binding for binding 0. So whatever bind group this is in, if it was in like bind group 2 or something like that, then we would have bind group 2 binding 0, and that would be this time buffer. And if we look at our WGSL, we can see that's exactly what happens. So we define a struct called time. We could call this whatever we want, it doesn't matter. And then we have an ordered list of fields that have types that correspond to the data that we have in our buffer. And this binding, in this case, it's bind group 2 with the binding ID of 0, like we talked about before. It is a uniform, so it's a read-only value. And then this is a value of time. So the buffer and this time struct have the same layout. In this case, it's only an F32, so we just get the time since startup right out of that buffer. And then we store this bind group on the time meta. Now we get to one of the really chunky parts of this, and that's creating our custom pipeline. If you are working with bevy 0.8, you won't see this derived resource on top. Don't worry about it. This is something that's going to come out in bevy 0.9. So they've made basically deriving a resource need to be explicit, whereas in 0.8, we could just delete that and it would still run. So this custom pipeline holds a handle to the shader that we're using. We hold the mesh pipeline, and then we hold the bind group layout that we're going to use to put the time values into. So in one hand, we have the bind group. We have the actual data and the buffer that we're going to put onto the GPU. And on the other hand, this layout here, we have the definition for the memory layout for what this buffer is going to look like. And you can see that here in the from world implementation for the custom pipeline, which gets called when we initialize this back up top. We take the GPU and we create the bind group layout with this descriptor. And then we get a list of entries. In this case, we only have one entry. We only have the time. We've defined the time as binding 0. Once again, we say that the binding is visible in the fragment stage. So not in the vertex, not in a compute shader, but only in the fragment shader. And then we define the type as a buffer. So we talked about this earlier. Our bind group value is a buffer. So that's why we're saying it's a buffer here. The type of the buffer is a uniform. So it's going to be read-only data. And in this case, it doesn't have a dynamic offset. And the minimum binding size is a buffer with the size of an F32 in it. And then we get the mesh pipeline as well, and we return this custom pipeline struct initialization. So again, this from world is basically like the same as implementing default, except that we get access to the bevy resources that we could otherwise query for. Then we have to implement specialized mesh pipeline for our custom pipeline. And honestly, this is one of the parts that is the most opaque to me. So I'm mostly going to gloss over it. And maybe I'll make another video in the future on what exactly this is doing. But again, in a similar way to the way that we set up the bind groups, we construct a descriptor for what we want this to look like. And then we return that descriptor so that the GPU can create it or bevy can create it or something like that. So draw custom, once again, is the draw function that we are choosing to call in our transparent 3D phase. Each of these is a different bind group. So in this case, we've got the mesh view bind group. In this case, we've got the mesh bind group. And in this case, we've got the time bind group. If we look at the values that we are binding to inside of our shader here, we've got bind group number 1, binding 0 is a mesh. So if we look at bind group 1 right here, it should be a mesh, and it is. So by defining this draw function and passing in these type argument IDs, we are defining which bind group each of these things is going to be set as. So if we need the mesh view stuff, it'll be in bind group 0. If we need the mesh stuff, it'll be in bind group 1. If we need the time, it'll be in bind group 2. And that is true because in group 1, we have the mesh. And then in group 2, we have the time. But these have to be implemented somehow. So we have to set a struct called setTimeBindGroup. In this case, we use const I, which is some size, as a type argument so that we can pass in whatever index or ID we want. Again, those are used to define what the IDs for the bind groups are. And then we implement entity render command for this setTimeBindGroup. Now, sres here we can see is just a resource with a static lifetime. So the associated type param we are setting to a resource that is time meta with a static lifetime. This is one of the ways in which bevy kind of gets into more advanced type system shenanigans. So we're going to skip this for now. We're going to skip the implementation anyway and just say that the param is the time meta with a static lifetime. And we have to implement this render function. We get access to two variables here. One is time meta, which is our system param item, which is this time meta right here with the static lifetime. That's what's coming in right here. And then we get a pass, which is a tracked render pass. And basically the rendering in bevy happens in passes. And a tracked render pass is a render pass that tracks the current pipeline state to make sure that all of our draw calls, like the things that we were defining before, are valid. The docs also say it's used to set the current render pipeline, which we've specialized, bind groups and buffers. And we can see a little bit more about render pipelines here. So a render pipeline represents a graphics pipeline and its stages, which is shaders, bindings, and vertex buffers. So it's the whole collection of the data that we're operating on and the code that we're using to operate on it. That is on the GPU. So implementing this render function for entity render command, we get the bind group by taking the time meta and grabbing the bind group as a reference. And then we just set the bind group on the render pass just directly. And this is because we set it up to be able to do this, basically. We stored this bind group in here earlier, so then we have the data when we need to actually use it here. And that's it. So it's a little bit more complicated than the way that we've been doing shaders and materials and stuff before, but it's also significantly more flexible and allows us to set up kind of any kind of data from anywhere. So if we had any value that we wanted to have in the bevy world that we wanted to pull into a shader, we could do it using these extract techniques. And then we can prepare those values and set them up in bind groups and send them to shaders. So for example, if you wanted to set up a health bar and you wanted to track some value that was tracking the health, you could pass that value really efficiently into a bind group with a bunch of other data and then use that value in your shader to determine, the color of the health bar or how much it's full, right? In my case, what I'm using this for is I'm trying to set up a volumetric rendering texture, which is a little bit more complicated than this. So this was our intro to the lower level APIs inside of bevy. And then we'll go over it again whenever I get that volumetric texture working. And if you don't know what I mean by a volumetric texture, if we search for something like a volumetric 3D texture from Houdini, we can end up with things like this cloud on the right, or these clouds right here, or something like that. So we can take the data that is like a 3D set of slices kind of, and we can look into that and use that data to render out clouds in different spaces inside of a cube bounding box. So we'll go over that when we get to it. But once again, I hope that this was useful. I hope you enjoyed it. I know this was much more complicated than we usually get into, but as I learn more about the internals, I would like to share that with you. If you are enjoying sort of the lower level stuff, I'm happy to answer questions or explore more. Just leave a comment, and I will see you in the next video. Have a great day.